Huawei Xingmai Passive Ethernet Network PAN solution is an all-optical campus network solution based on the passive technology. A PAN typically consists of PAN central switches, central optical modules, passive aggregation modules, remote optical modules, and access switches and access points with optical uplink ports. There are three typical networking schemes for the PAN solution. Typical networking scheme 1. Both passive aggregation modules and access switches use single uplink transmission. This scheme is ideal for scenarios with a strict network construction budget and relatively low reliability requirements. Typical networking scheme 2. Passive aggregation modules adopt single uplink transmission in which master and slave ports are connected to two different central switches. And access switches utilize single uplink transmission. This scheme is ideal for scenarios with a moderate network construction budget and high reliability requirements for the backbone network. Typical networking scheme 3. Passive aggregation modules use single uplink transmission, while access switches employ dual or multiple uplinks, connecting to two or more different central switches. This scheme is ideal for scenarios with a substantial network construction budget and very high reliability requirements across the entire network. Main components: PAN central switch. A PAN central switch provides 6 CFP to optical ports, each supporting 16 10G SFP plus channels and connecting to up to 96 10G access units. PAN passive aggregation module. A PAN passive aggregation module has two modules which support a transmission distance of 2 km and 10 km, respectively. The PAN passive aggregation module panel offers two port groups, each supporting one channel up to 8 passive optical splitting and providing one uplink port and 8 downlink ports. Each uplink consists of M master and S slave ports. The uplink port is connected using single-core LC fiber, while the downlink port is connected using dual-core LC fiber. PAN passive aggregation module subrack. When installing the PAN passive aggregation module in the cabinet, it can be used together with a PAN passive aggregation module subrack, occupying 1 U height. Each subrack can house 3 PAN passive aggregation modules, together providing up to 48 downlink ports. PAN central optical module. Each PAN central optical module provides 2 single fiber bidirectional LC ports, each supporting 8 channels of signal transmission, which correspond to 8 logical ports of the PAN central switch. Each logical port supports a rate of up to 10 GE, with a total of 80 GE per LC port and 160 GE per PAN central optical module. PAN remote optical module. There are 8 types of PAN remote optical modules, 1 to 8. Each type uses a different pair of transmit and receive wavelengths, which correspond to those of the PAN central optical module. The PAN remote optical module is installed on the optical uplink port of an access device and supports both 10G and 2.5G rates. Each LC port of the PAN central optical module corresponds to 8 different PAN remote optical modules. Xingmai PAN solution, planning and implementation. The overall deployment of the PAN solution can be seen on the screen. Central switches can be installed in the central equipment room or in the building equipment room. Passive aggregation modules can be installed in the building equipment room or in the floor ELV well. Remote access devices can be installed in the room information box or in the corridor wall-mounted cabinet. During PAN construction, the quantity and installation location of modules can be flexibly planned according to the campus size and the number of access devices. Adopting a more centralized approach to installing central switches and passive aggregation modules results in higher port utilization and lower device costs. As shown in typical scenarios 3 and 4, the PAN central switches are installed in the core equipment room, and the PAN passive aggregation modules are installed in the building equipment room, eliminating the need for floor ELV rooms. Before the construction, plan device IDs and port mapping based on the network scheme design, and record them in the Xingmai PAN network device and port information planning table as a reference for subsequent construction, maintenance, and management. You can download this table from the Huawei technical support website. The screen shows the mapping between physical ports and logical ports on the PAN. You can view CFP port IDs, included port group IDs, and logical port IDs on the PAN central switch panel, or by running the display device WDM port mapping slot command on the device. The logical port ID corresponds to the PAN remote optical module ID and is not related to the port ID on the PAN passive aggregation module. In both mixed and non-mixed scenarios, there is no difference in the mapping between logical ports and optical module as queried by the display command on the device. Take the remote optical module A3 in the figure as an example. In a non-mixed scenario, it is connected to port 3 of group 2 on the passive aggregation module and corresponds to logical port 10G1027. In a mixed scenario, it is connected to port 1 of group 2 on the passive aggregation module and also corresponds to logical port 10G1027. The PAN passive aggregation module provides a port mapping label which records the installation positions of the master and standby central switches connected to the module and the mapping between their logical ports. After the information planning table is completed, the installation positions of related modules and port mapping are determined. For easier installation and more efficient engineering, you can label related modules in batches. You can either handwrite the port mapping on labels or print and stick them. If handwriting labels, you are advised to use a permanent marker. If printing labels, you are advised to use a handheld printer. Such printers usually support custom label printing paper, and the specifications of custom labels are shown on the screen. Device installation and cabling involve 3 parts whose steps are detailed as follows. Install a PAN central switch in a cabinet. Install an optical module on an uplink optical port of the PAN central switch and connect optical fibers to an uplink optical distribution frame ODF. Install a PAN central optical module on the PAN central switch. Use an LC jumper to connect the PAN central optical module to a downlink ODF used with the PAN central switch or a PAN passive aggregation module. Install a PAN passive aggregation module. Install a PAN passive aggregation module subrack in a cabinet using mounting brackets and install the PAN passive aggregation module in the subrack. Use a single-core LC fiber jumper to connect an uplink port on the PAN passive aggregation module to a corresponding uplink ODF port. Use dual-core LC fiber jumpers to connect downlink ports on the PAN passive aggregation module to the corresponding downlink ODF ports. Install an access switch or remote unit RU. Small-sized rods can be installed in information boxes. Install a corresponding PAN remote optical module on the access switch or RU. Connect optical fibers to the PAN remote optical module. After the installation and cabling are completed, label the corresponding cables and properly bind and place them. The PAN solution networking diagram is shown on the screen. The PAN central switches device 1 and device 2 are stacked, with device 1 acting as the master switch. To ensure high reliability of links between core and access devices, device 3 is dual home to device 1 and device 2 through a PAN passive aggregation module. The PAN central optical module is installed on the CFP222 ports of device 1 and device 2. And the PAN remote optical module A2 is installed on the uplink 10G optical port of device 3. according to the mapping between physical ports and the logical ports on the pin mentioned earlier. The logical ports connected from device 3 to device 1 and device 2 are 10GE1026 and 10GE2026, respectively. You can also run the display device WDM port mapping command to query the logical port IDs. The configuration roadmap is as follows. Add 10GE1026 and 10GE2026 on device 1 and device 2 to as trunk 26. Configure as trunk 26 in manual 1-to-1 master or backup mode for dual uplink high reliability. The master port will forward traffic, while the slave port will act as a backup for forwarding. The configuration procedure is as follows. Step 1. Create as trunk 26 on the stack and configure a VLAN that is allowed to pass. Step 2. Set the working mode to manual 1-to-1 master or backup. Step 3. Add member ports to as trunk 26. Step 4. Run the display as trunk 26 command in the stack system to check whether the master or backup trunk mode is configured.